All, can you hear me? Just to check if everything is okay from my side.
Yes,
Yeah.
we can hear you. And your screen is
Thank
on.
you.
That's fine.
Yeah, I'm Sunil Kumar, responsible for Kuwait and Egypt GFD product line. And today we are discussing about one of the most innovative products called ELDS. And agenda is to cover ELDS product overview, how does it works, why to use it, application, and summary. Okay, the first thing which we would like to highlight the product overview. What is it basically? This is nothing but an open path, same like traditional open differential IR, but this is a laser base used for hazardous area gas detectors. What it does, what does it detects? It is a target gas specific for a range of flammable and toxic gases. And ELDS stands for Enhanced Laser Diode Spectroscopy. That is the complete name. And what is the difference between ELDS and TLDS, which is used earlier? TLDS is nothing but which was used traditionally in the process analyzer much before the ELDS developed in the market for gas detection. But that was mainly used for process control application under the control environment. Now, ELDS is an enhanced version of same technique, providing a more robust solution in open ambient test mode. Okay, so the ELDS provide advanced false alarm rejection in open outdoor environment from interference gases, vibration, etc. That is the basic difference between TDLS and ELDS. Where it is used, industrial, indoor, outdoor application in hot and cold climate for both the condition. And this is system architecture, absolutely same as our traditional differential open path IR, except the sensor is laser. All the specification, this also works for the 24 volt DC. This also works on different distance, operating distance, and all. So absolutely, this is well known to you. But how do conventional TDLS and ELDS device works? Because already TDLS was in the market long before the ELDS got into the market. Okay, so there is a transmitter here, and this is a receiver. Traditionally, for all the open path detector, one transmitter and one receiver is there. And in the transmitter side, the laser is there. So when there is any gas, the transmitter transmits the light, and if there is any gas, target gas, it hits the gas, and where there is absorption of the infrared radiation, and that absorption basically generates harmonic fingerprint. And you can see the harmonic fingerprint because every molecule has its own unique harmonic fingerprint. The same way like a human being, the human being also have a unique fingerprint. Every human has a different fingerprint. The same way every molecule has a unique harmonic fingerprint, and that is a set of harmonic component. Okay, there are various number of harmonic component introduced by the target gas absorption in which the relative amplitude and phase of the component. So every harmonic fingerprint has its own phase angle and its own amplitude based on the concentration of the gas. Amplitude may vary, but the phase of the component will remain same. So you see the typical H2S, which is at 1589 nanometer. You will find typical harmonic component of that component like this, okay, which is fixed irrespective of whatever technology you use. The harmonic fingerprint of H2S will remain same. Now the difference between TDLS and ELDS is that TDLS use only the second harmonic of that harmonic fingerprint, whereas if you use ELDS, we use not only second, but we use third, fourth, and fifth harmonic. Okay, the more harmonic you use, the more certainty of the component you get. Okay, so when you pass through the immigration, you might have seen sometime you give only one finger, sometime you give complete 10 finger. Okay, so the more finger you get through the scanning, the more certainty of the individual come across. The similar analogy is applicable in ELDS. So because second harmonic may be generated because of the noise, because of the vibration, because of the interfering component, because of the neighboring component. So second harmonic may be generated by so many other reasons. So unless and until you measure third harmonic, fourth harmonic, fifth harmonic, which is a characteristic of a certain component, you will not be able to eliminate false alarm. Okay, so it is mandatory to have more harmonic rather than single harmonic. Single harmonic is good as long as it is used for the process control atmosphere, either in the shelter, either in the cabinet, or anywhere which is a no effect of other adverse condition. So if you see, how does ELDS different? This is a conventional TDLS and this is a Senscient ELDS. They measure only second harmonic, and second harmonic can be generated by vibration, poor weather, neighboring component, interfering component, noise, so many other parameters can generate second harmonic. And that is the reason false alarm is possible if you are going to use for the outside application, not for the control application. Our gas detector always used for the outside application mainly. Whereas ELDS, they measure not only second, they also measure third, fourth, fifth harmonic. And that is why we say no false alarm because of that. And this is a target gas specific because this is a laser, so it is always specific to one particular component. Alloy greater sensitivity, we can go down to the lower sensitivity. And that is the reason this is our patent harmonic fingerprint, which eliminates, confirms no false alarm. Okay, that eliminates false alarm. Now, when it comes to the H2S, is a different altogether because most of the component measurement we use single laser, but H2S being a very heavy gas, unlike any other gas, because this is a low absorption coefficient, 10 times lesser than the methane, So using single laser, it was not possible to give you complete measurement of H2S. So what we do, we use two lasers. You can see that in the transmitter side, there is a blue line and there is a red line. And this is a gas, target gas, typically H2S. So when the laser hits the gas, there is a harmonic fingerprint for the blue. And when the red hits, there is a harmonic fingerprint for the red. And the gas then the laser signal get distorted. The amount of distortion is proportional to the concentration of the gas. So what we do, we use two lasers. We use two harmonic fingerprint and one harmonic F, 2F, 3F, 4F, 5F, 6F, 7F. So, and through the second laser, we again have the same harmonic fingerprint because we are measuring only H2S. So as long as it is H2S, the phase angle and amplitude will remain same. So you can see F dash, 2F, same amplitude, 2F dash, 3F, 3F dash, 4F, 4F dash. So we use 4 harmonic from the one laser and 4 harmonic from the second laser. Out of 8 harmonic, we ensure that 6 out of 8 has to match. Okay, one may be because I told you the second harmonic may be generated because of the vibration, noise, interfering component, so many other things. So we ignore the second harmonic sometime. Okay, but out of 8 fingerprint, okay, 6 has to be matched. And once we do the voting and we get 6 out of 8, confirm that this is H2S. Unless this is matched, we don't report that there is a H2S gas leak. So we do so much, voting, so much logic behind to measure H2S. And that is why if there is any kind of gas, and if there is any 4 to 20 milliampere you get, that means there is H2S gas leak is there. Okay, so dual frequency harmonic fingerprint comparison for highest false alarm rejection. That is what. So H2S, if you are going to measure, you need to have 2 lasers, and then we use 6 out of 8 voting. So much things we do to ensure that there is a H2S gas leak and measure, and there is no unwanted false alarm. Now, let us talk about typical example of methane. We know that traditionally since last 50 years, we are measuring methane through the traditional differential IR. And the differential IR, if you talk about, they have the bandwidth of 150 nanometer. Whereas if you talk about laser, that has a bandwidth of 0.1 nanometer, because this is a target gas specific. Very, very narrow bandwidth. That means if you see this has a bandwidth of 0.1 nanometer, this has a 150 nanometer. That means if you use laser, you will have 1500 better resolution. Okay. And that is why, because if you see 150 nanometer, that means within 150 nanometer, we are totally blind. We don't know where there is interference happening because of water vapor, because of the hydrocarbon gases, because of so many other things, because water is everywhere within the 150 nanometer. So you compromise on when you are measuring through the NDIR principle. But when you measure through the laser, you have accurate measurement, you have no interference from the any other hydrocarbons, no cross interference from the water vapor. So it is true to CH4. And that is why we say laser is very much target specific and free from water vapor, free from any kind of hydrocarbon gases. And the latest example, which we have successfully done the trial at LNG Kochi plant in India, they were using the traditional IR open path. And when we replaced with our ELDS, we found there is no false alarm. Earlier, they were suffering with so much false alarm because you can see so much fog because of cooling tower was next to these devices. So throughout the day, they were having so much false alarm. The moment we install laser ELDS devices, absolutely there was no false alarm. So they were very happy with these devices. So why do we use ELDS? My next thing. Because ELDS is the one device which ensure no false alarm. That means maintain production continuity, because any false alarm has huge shutdown problem, and huge cost to the plant. So since there is no false alarm, so huge production continuity and fail-safe output. This is also helping maximize system availability. The second point is reduce H2S, because this is a very fast, true to the target gas, very reliable, fast response time and reliable detection. Minimize operating life cost, because this is the one device which I will explain you how this reduces the operating life cost, because this device doesn't need any calibration, this device doesn't need any routine calibration, this device doesn't need any kind of sensor replacement so often like any other gas detector. So huge operating cost saving. And since you have all three, definitely this protect business reputation. If you select best sensor available technology in the market today. Okay, now I'll go one by one, because I have given three major points. Maintain product continuity. How? Because since there is no false alarm, because of sandstorm, vibration, weather resilience, very high certainty. And ELDS we have already talked about, because ELDS is the one device that works on the harmonic fingerprint, where we use 4 harmonic versus 1 harmonic. So that eliminate false alarm, fail-safe output, reduce H2S risk. This is another very important thing, because any point detectors or any open path, nobody will give you so fast response, less than 5 seconds, sometimes less than 3 seconds for methane, this 5 seconds for H2S. That means if you have a faster response time, means faster hazard mitigation, unlike any kind of point detector and traditional point again. The sooner you get response, the sooner you can take the action for that. Sandstorm resistant glass optic, you can see the optics, which is a very much resistance to any kind of sandstorm. Reliable operation in Middle East climate with enhanced sunset. We have a typical sunset design, because this device is very much sensitive to the temperature. So we have developed with the enhanced sunset design, which has very much suitable for the Middle East application. Now, when we say that the ELDS 100% certainty of this, if there is any leak, that it will detected. So how to ensure that it is 100% reliable gas detector? Okay, because we use the technology called laser, and laser, when we use, laser is being a semiconductor device which has its own property, as the laser has its own drift with uses and its edges. Okay, so how do you ensure that laser has no drift? Because laser, if it is you are measuring H2S, which is 1589 nanometer, we ensure that laser throughout 365 days it emits 1589 nanometer only. If there is a small 1 nanometer here and there drift, even though H2S is there, it will not be detected. So we have a technology called laser lock. Okay, and through the laser lock, what we do, you can see this is a transmitter side, this is a line diagram of transmitter side, and other side there will be a receiver side. So the transmitter side, we have a laser inside. So when the laser emits the light, 99.9% light goes to the receiver side, 0.1%, which is shown by the red color, okay, it goes to the gassing cell. This gassing cell is a big innovation, because gassing cell, if you are using H2S, pure H2S gas will be filled in that. If you are measuring methane, pure methane will be filled in that. So when the laser emits 1589 nanometer, the inside also there is a H2S. So this will also have correction 1589. So there is no absorption. When the laser drifts, let's see 1590 nanometer after 2 month time. So this red light goes at 1590, whereas H2S here will check, okay, this is coming 15. So there will be a drift. So this detector will check there is a drift. So whatever drift is there is a microprocessor here. So microprocessor will be comparing as a live time, real time comparison. And whatever drift is there, that much milliampere gain will be given to the laser diode, so that whatever drift is there, that much milliampere is given to the laser diode to make sure that laser always emits the same frequency 1589, no drift at any point of time, so that laser always locked at certain frequency. That is the beauty of laser lock. And this gassing cell we also call SIMU gas. I'll explain you in the next slide. So laser lock helps you to ensure that it always detects H2S all the time. If there is a leak, it will detect. So this is a 100% certainty of detection if there is any gas of H2S leak. Okay, seal. This cell is sealed for life, no maintenance. So far, we have not replaced anywhere. So this is a life, no maintenance. Now, minimize operating life cost. We were talking about SIMO gas. Okay, because of the SIMO gas, what is happening is, since this gassing cell is a pure H2S, right? So we know what would be the harmonic fingerprint, okay? Because in known component, known concentration, so harmonic fingerprint of that particular gas is known. So what happened? This is a transmitter and this is a receiver. So receiver, we have already fed that this component will come once in a daily, okay, maybe 10 a.m., maybe 9 a.m., once in a daily 24 hours. So the transmitter will tell to the receiver that I'm going to do the validation every 10 a.m. on daily basis. So that time the transmitter receives the signal, transmit the signal to the receiver. Receiver knows that it will be H2S at certain concentration, certain harmonic fingerprint will come. So this and this, they compare each other, and if both are same, they give you complete functional validity. So this is a validation done every 24 hours, once in a daily. So no visit required when using daily automatic functional test and remote retrievable test report. So this is the beauty of validation, and that is why I say we don't need any calibration, because we do the validation on daily basis. And during that validation time, okay, this 50-second will be on hold. Analog 4 to 20 milliampere will be on hold at that point of time. And we have the capacity, the event log capacity, 86,000 data can be stored. And so this is a SIMO gas end-to-end functional test, same like, in piano synthesizer, when you touch, it will transmit the same frequency all the time. So duration less than 50 seconds, Bluetooth hardware activation, retrieval that we talk, SIMO gas auto. This is happening. We call it auto because it happens automatically. But if you want live at any point, because we have set 10 a.m. every day, but if you go to the field and do it at 9 a.m., so you can do it, that we call it SIMO gas live, functional test on demand. Okay. So because of SIMO gas, because only Senscient device ELDS has a unique daily automatic end-to-end functional test, we call it SIMO gas auto. And because of that, no routine manual gas testing is required. No need for anybody to go to the site. That means remove personnel from going to the risk environment, reduce labor and logistic costs, requires no H2S test guide during commissioning, So no gas cylinder is required. Reduce operating cost, no calibration gas required, no replacement sensor. Okay, so huge saving because of this technology, CMO gas auto. And laser lock help you to ensure that 100% reliable detection. So these two things is very important. Why we use laser gas detector? Because the speed, which we talk about, less than 3 seconds, less than 5 seconds, depending on the component. And sensitivity, we can go down to very low ppm, okay, 200 ppm for a methane. Coverage detects a very, very broad area. Okay, if you go for the methane, it can cover up to 200 meter, but if you go for H2S, it can go up to 60 meter distance. Okay, no interference or false reading because target gas specific. Laser only detects one component at a time, specific to particular component. Gases are toxic and flammable. Safety integrated, no unrevealed failure modes. Okay, no false alarm because this technology work on harmonic fingerprint. High sensitivity, dual laser because we use dual laser. Multi-gas, we also have the component dual laser for one for methane, one for H2S. Automatic gas testing, CMO gas auto, which we talk about. No gas handling hazard, CMO gas live. Detector test record, 86,000, which we talk. Now coming to the application where we use this product, because this is such a good product, we need to know where to use. The best application which we come across is the perimeter application, large area. Because if you use point detectors, there will be huge number of point detectors, so many IO count, you know. So it will be difficult to have so many IO into control your control DCS. Traditional target all traditional IR point open path gap where customer is facing problem because of fog and rain, which we talk about LNG Kochi. They were suffering with fog, you know. So anywhere, if they are using traditional IR, they will be facing problem because of fog and rain. So target those customers, and I'm sure you will be successful for those customers. Ammonia plant, very good application. Nobody have for that. Chemical plant, HCl, we have a good application. HF, another application. Ethylene, that is another one. Gas processing, LEL.ppm. FPSO, that is again very good. NGL plant, offshore rig, refinery. And another very good application, HVAC inlet. You know, this is the one of the best application where T90 less than 1 second. No device ever got in the market which gives you T90 less than 1 second. Not only that, the range 0 to 10%, 25%, 100% failure. Nobody will give you 0 to 10%. Yes, 0 to 100%, but 10% nobody will give you. Okay, so this is one of another very good product which anybody HVAC customer will love that. So far we have the list of the gases which we have developed. Okay, CH4, combined methane and H2S, ethylene, which we talk about, CO2, H2S, HCl, HF, ammonia. So we have good number of detectors. So now we conclude what is the major benefit of this? Increased safety, which we talk about, because no need to go to the plant area. H2S is a very risky area, so you can remove your personnel from going to the risking area. Greater detection coverage. If you go for methane, 200 meter we cover. Fastest plant shutdown because the response time is very fast. Eliminate false alarm because we follow the technology that is called harmonic fingerprint. Increase availability, best environment resistance. Easy to install and align. It's like a fit and forget. Reduce capex, reduce point detection count. If you go for perimeter application, reduce system IO count because every 5 meter, 10 meter, you have to put point detectors. Now you can put at least 60 meter away. So you can reduce. OPEX, automatic daily gas testing because of CMO gas. No need for test gas cylinder, no consumable, no sensor replacement. So if any customer who is looking for gas detector, which doesn't need any calibration, doesn't need any sensor replacement, less maintenance, less capex and OPEX, this is the best. The search is closed, search is over. This is the device has the power. So I give you any ELDS best available technology available today. And thank you. If you have any question, please feel free to ask.